We don't have recent files, so that's going to be interesting.
No, there it is.
Okay, so let's finish our block statement. We left it hanging just a little bit, but we're going to actually upgrade it from what we were having anyway. So here's our block expression. Sorry, expression, not statement. We haven't gotten to statement yet. That's going to be when we switch to a different type of language when we think about things in terms of statements. Okay, so we are getting our, in fact, actually, let me do this. I'm going to change the way we're doing this anyway, so I'm just going to backspace this. Well, let's not get rid of all that. All right, so I have my list of lambda calculus expressions. This is everything but the first element, because the very first element is the word block, right? So then I have this lambda that's going to take in a list of expressions and the current environment. Now, one of two things can happen here. Either, well, if I'm out of stuff to process, then I'm done. So if that's the case, I end in the empty list, and that just becomes the last part of my cons, and we have our list of executed expressions. Otherwise, if I'm not looking at a remember expression, then I want to call apply expression on the first part of it in the current environment, and cons that onto calling process on the rest of it with the current environment. All right, so that's what we do if we're looking at something that is not a remember expression. Remember expressions change the environment. That's what their job is. And that environment should change. And I think last time we decided that we're supposed to put a true on there that something happened. We wouldn't need to do that if we didn't want output, but it should actually have an impact. All right, so else we're going to go ahead and tack on a true because we did something. Now, what are we doing? We need to extend our environment. Now, I'm calling apply expression and I'm passing it the cdr of this guy, but we're going to handle this a little differently. So I'm going to kind of backspace here. All right, so we're going to start thinking from this point. So we're going to say, I'm going to cons the true because we're going to be extending the environment. Now, what do I actually want to do? I want to call process on the rest of it. So let's start with that. So, well, we can actually do this a couple different ways. So I can, if we extend our environment with the car of the list we know is a remember expression if I'm in this else, right? So if I extend my environment, that's the new environment in which I want to apply this block expression, right? Does anything actually keep me from calling the global apply expression again, passing it a new block expression with what's left of my list of expressions and my updated environment? So we have a constructor for block expressions, right? This guy right here that takes in a list of lambda calculus expressions and he builds me what a block expression looks like. All right, so if I'm in this else here, I know that I am dealing with a remember, so I need to have a new environment. That's the extension of my current environment. But I also know that the cdr of that list of, list of lambda calculus expressions, these guys, is, there might be another remember at the front, but not my job to handle it necessarily, right? So I'll say, as far as I know, the rest of that list is the list of lambda calculus expressions for a new block expression. Make sense? Now, what does a block expression return? It returns a list. I ultimately want to have a single list with all this stuff in it. How do I get two lists to glue together into one list? Cons gives me, cons an element onto the front of another list. Yeah, append. So else, I'm going to, I want this true, I guess. We decided that's a thing. Okay, so I'm going to append the list containing true, or if you prefer, you can say the list of true. All right, so that's my new element. I'm going to append that onto whatever's returned for apply, make sure I spell it right, apply expression. Apply expression, and I'm going to kick this down a line so we have some space. And apply expression requires me to give it an expression. What expression am I going to give it? I'm going to give it a newly built block expression. So I'm going to say block exp, and this guy takes in a, what's it called? List of lambda calculus expressions, this guy. So I'll create a block expression out of the cooter of this guy. Because I know the car of that guy is my remember expression, right? All right, so I'll, in fact, we would make a, if you really wanted this to be more easily read, we would say this is a let, and we'll say remember exp is equal to the car of low. Do I still have this copied? Maybe not. That's what my remember exp is going to be. And then my rest of exps will be the cooter of that guy. And then all this stuff is happening in the body of this let. So I'm going to append the list that's true onto apply expression of block expression on rest of exps. Passing it a new environment. So, so there's my block expression. An apply expression requires an environment. I need to pass it a new environment. What environment am I going to pass it? I'm going to pass it the environment produced, because if we look at a remember expression here, what does remember expression boil down to? It boils down to an extended environment. So I'll call apply expression. All right, so there's apply expression, and the expression we're applying is my remember expression. In the context of our current environment. So this guy right here will boil down to a brand new environment. Okay? This will be our updated environment or something like that. Now, if I wanted to extend my let, I could take this guy, move it up here, and I can say new env is equal to apply expression, remember So I could say that that is my new env, but then I'd need to, in order to make this work, I'd need to upgrade my let to a let star. Because let stars allow me to use variables that I previously defined inside the let. Okay, so now I'm going to have my remember expression. I'm going to have my rest of expressions. I'm going to go ahead and get my new environment by calling apply expression on that remember expression that I extracted right here in the current environment. We know that this guy will boil down to an extended environment. So now what I can do is I can append the list that is true onto what's returned by apply expression. Oh, Ninja. I'm lost. Here we go. Onto apply expression, passing it my new block expression and passing it my new ENV. Because that's the guy in which the rest of this block, as far as I know, should be executed within. That makes sense? So what we're doing is we're saying, hey, I see a remember expression. I'm going to go ahead and make a new environment. Then I'm going to say, now treat everything else that's in here as a brand new block expression that continues from this point on under the guise of this new environment that was just built. That makes some sense? All right, so now I should be able to.
I have a question.
Yep.
So then, does this way you're writing is more beneficial compared to the last one that you're writing?
Yeah, this is better. The way I was writing it before would have worked, but I was effectively writing redundant code because I was creating the logic of walking through my block expression and determining if it's a remember expression, do one thing, otherwise do something special otherwise. Where I was going to just bump ahead to the next expression and process it. And then I kind of put in there that we have to deal with like an empty list as the last one is the special case in case their very last dying wish in their block expression was to extend the environment for some reason. You know, like the very last line of your program in Java is int a equals 7. If that's the very last line, okay, you're not going to use that variable. That is a waste of processing power, but it is technically legal. You can just have a whole program just defining variables and do nothing with them ever. But we would have had to handle that as a special case. And this is substantially better. Because really, what's a block expression? A block, and we can think about it generically like this. A block expression is a collection of normal expressions mixed in with remember expressions, right? Because remember expressions, those are our special cases. They give us new environments in which we need to execute the future things in. So all I'm doing here is I'm saying, if I bumped into a remember expression, if I'm in this else, I'll go ahead and extract my remember expression. I'll go ahead and get the rest of my expressions. Those become the body of the new block expression. And then I'll generate my brand new environment. That's the environment that is extended with this remember expression. And it's the environment that I'll execute my newly formed block expression with the rest of my stuff in. Go ahead.
So when we're passing that new environment, is that new environment technically like overriding the current environment?
Mm-mm.
Or it's something separate that's in memory, and when we're done with apply expression, that environment is gone?
Correct.
So
Yeah,
how
we're not overwriting the value. It's only going to live so long as we are in the block expression,
so if we
i.e.
wanted-
local scope.
Okay, so if we wanted to like use that block expression as like, if we wanted to use a block expression as like a constructor to update our environment and then essentially apply another block to it that would, you know what I'm saying?
You mean put a block expression inside of a block expression?
No, I'm talking like two separate iterations. So like do this block, then this block?
No, it wouldn't because a block has its own local scope.
Okay.
But you could use a block expression
In a block.
as a constructor,
Yeah.
as you kind of put it, where it creates an environment and then have a block expression inside of that, which is maybe funky when we think about it in the context of Java,
Yeah.
but not really. I mean, Java, you have an open, closing curly braces, that inside there you have a for loop that has its own local scope.
It's a block within a block.
Yeah, so those things exist. So, but it doesn't even matter if we can't necessarily match it up to an existing language.
Right.
So for us, if we want to have a sub-block where our variables live and die only inside that sub-block, we now have the ability to create little local scopes. But once that block is done, all those scope changes are gone. We're back to our normal ENV. So in our example here, if we have a block inside of a block, and we can actually, let's create our test expression here. So we're going to create a block exp, and this guy is going to be a list of things. So he's going to be a list of a remember expression, and then maybe have an app exp where we pass it a lambda exp, where this guy takes in, what is he taking, a list of inputs? I think our constructor for lambda exp takes in a list of params. Yeah, list of symbols, and then lambda calculus expression. So we'll have our list of symbols is going to be our x there, but this guy is actually going to be, that's a list of symbols. All right. And then we're going to just display or boil down to a var exp, which will be our variable x. So that's our lambda expression, and we're going to be applying this to our var exp of a. And here, let me kick this down the line so it's a little easier to read. All right, so my block expression is a list of expressions. First expression being, remember that a is 5. Second expression being an app expression, where we're going to have the first element being a lambda expression that takes in a single parameter x and boils down to the value of x. The second value of our app expression is going to take in a var expression for this variable called a, which we've defined here. And our test environment does not have an a in it. We just have a c and a x. But right now we actually, since now we have remember expressions, we don't need our test environment anymore. Now we can pass this guy empty env. Right? Because now we know how to add stuff to our environment. We don't need to give it starter variables. Okay? So test environment's now out the window. I'll always start with an empty environment. So in my block here, I define a variable name a equal 5. Then I apply this lambda, which takes in a single parameter and just boils down to that parameter. And here's the value I passed it, which is a, which should only exist in the environment that was extended by this remember expression. That makes sense? And then, so we're going to apply that program. So if everything zigged and zagged, we should get a 5 out of this.
Your X and your A in single quotes.
My X, this guy, and this guy. Expected expression. Oh, did I build a let rec that I'm not calling? Oh, I must have ended my thing. Binding, but nothing's there. Process. We were in the middle of this lambda last time. Let's just test it. Okay, so that guy looks good. That guy does.
Oh, it's complaining that you don't have an actual body to the let rec. You just have 2 bindings.
Oh, yeah, thank you. So, all right, so there is the end of my. So we've called the right stuff here, people. We're fine. All right. So now our process function that we spent all this time writing takes in a list of expressions, which is this guy, right? And which is what that guy will be, and then the current environment. So I'm going to call process on low expressions and my current environment. Received an A as the last value. So this seems like it is a poorly constructed test expression. Expects. Oh, does our, well, hold on. That was
Block
for.
expression expects a
You need to
list
do like the
for
app
body.
exp old, like the old one, not the
Never mind,
new
you
one.
got it.
The old
Yeah, we updated our app expression. So app expression takes a list of expressions.
If you just put an exp and then slash o.
Yeah, but we don't want it to be all the way. But you're right. You're right. So, because we want to be able to pass in multiple parameters to a lambda that takes in multiple parameters. So we're using our newer lambda expression that can take in 0 or more parameters. So we need to be able to give that guy 0 or more parameters. So this is a list of those things, right? Or actually, if you, sometimes that looks a little cleaner rather than just having extra parentheses. So we'll have a list of those things. And there's our true and 5. All right, so now what we should be able to do is we should be able to create a, so that's my app expression. I'm going to go ahead and create another block exp, passing it a list of expressions. And I'm going to go ahead and have that guy boil down to my 5, because he lives inside of the, actually, I'm sorry. Give me a moment. I'm going to create a block expression up there. So I'm showing us a block inside of a block. So in this inner block, I'm going to remember a variable name. And then I'm going to have my app expression here that ultimately boils down to that value of that is 5. All right. Then I finish my block expression, and then I'm just going to have a var exp passing it a, which should give us a false, because that a only lived within this inner block expression. That makes sense? I created a local scope inside of the larger block. So I have a larger block expression here. And then inside that, I created another little local scope. In that local scope, I defined a variable named a equals to 5, and then I used it in here. But as soon as that block expression finished, what happened? We lost that extended environment. We're back to the original environment that does not have an a in it. So now it's, I think our apply environment gives us a false when it can't find the value. So we should get a 5 in that it found the a here, but we should get a false that it did not find the a outside of that inner block. Can I do the same thing again? Remember expression takes in a question expression takes in a, oh, why is it calling question expression? Is this formed correctly? My block expression takes in a list. So there's that list, and
I
then
think that's where the error was. Yeah, the error must be in something we wrote. We must have called question when we meant to say remember.
oh, you think in my, wasn't I was flipping those last time, wasn't I?
Yeah.
Is this my first bug? That can't be
Today,
possible.
Yeah. I think that might be
That was a good one.
I thought it was further up.
Yeah, it was further up. Question expression wasn't the error. It should be the very top that the error appears.
Well, yeah, so I can run this again real quick, so we'll see the error.
It's
Up
on
there.
55.
Up.
Oh, on 55, yeah.
Oh. So a remember expression Well, no, this should be okay. Takes in a lit expression.
It's in our question form. So
Are we already passing it
asking
to car?
if it's a remember.
So we're already passing it the car of LC expression, and then we're calling the car of LC expression, but it's already just the symbol.
Yeah.
It's not a list anymore.
But to ask if something is a remember expression, that means I should be passing it a list.
Yeah, so we might not be passing it a list in apply expression.
Yeah. I might be pre-extracting the car. And I'm guessing that comes from question EXP. Those pieces should be fine. It says expects a pair given an A, but that indicates that I'm getting into the wrong. That logic looked fine. So I still go back to this. Did I write something wrong in here? Because we had this originally. Okay, that guy runs fine. Then I put a block expression inside of that. So if I take that block expression and I wrap it in a block expression, passing it a list, where the first element is this guy, and the second element is a var exp for A. That's a legal block expression, correct?
Hang on. Can you?
No, because the
No,
scope of A
it's-
should disappear.
Well, right. It's still a legal block expression. I want it to be false.
Okay.
I think
That's-
we need another parenthesis. At the first block expression, because you need to put a list.
Oh, you accidentally put the var expression for the first one
Outside the
outside
list.
the close
Yeah.
of the list.
This guy?
No.
No,
Like
This
so
guy.
the var expression A is outside your list command.
I want it to. Oh, I see what you're saying. It's there.
There we go.
Now he's part of that. Now he's part of that. Then we have that. Okay, so we do have the same error. So this is when you put a block inside of a block. Why is putting a block inside of a block causing this issue? What funky stuff are we doing when we put a block? Go ahead.
I don't know, something you could try is just, like what I've done for my predicate for remember expression, I just did an and to check and see if it was a list first, and then also check to see if the car is equal to remember. So that way.
I kind of recall, didn't we say something about that? Like we're just going to assume it always comes in as a list? So, and that's fine. So that should fix it. But the question is why? Where are we? I don't want to just patch the hole without knowing where the leak is coming from. But what you're doing is for the predicate here, before we even check to see if it's equivalent, you want to make sure it's a list first. Otherwise, you just check. Well, you just return false. If it's not even a list, it's not that guy. But why is it coming in? Where am I calling? Remember,
figure out.
I thought that. Oh, here next.
Yeah, you're calling it
In the block expression,
Yeah.
so when you're.
Oh, this guy. So I'm calling the car. Isn't that kind of cool? How you can do the search, and it circles it.
Oh, so if you just make it as a list down the var, would that?
Well, what's happening here is I'm checking a var expression. Well, no, my remember is going to take in. I have a thing called list of expressions, but in this case, I only have one value in there.
So if you turn that value into a list, would that work or no?
So what does this guy actually look like here? When I come into the lambda.
Because like that is a list, and then your var is just like a variable. So then when you go to the second one, because it's block going 1 and 2, so when that pass in, the var is not legit. Maybe, I don't know. That's what I'm thinking.
Yeah, so it's right here. I'm asking this question. So this just has to do with our block expressions. I'm asking whether that guy is a remember based on, I'm just saying, is the first dude in my list of expressions, is he a remember? So the question is what are my options for that first dude? If I come down here to this code, my first dude here is a block expression, right? First dude here is a block expression. And so I'm saying, is the first guy a remember? So I'm passing it the car of that, which is giving me, where does the A come from though? Oh, it's from it starts in another place. So I'm passing it the car of that list of expressions, which is going to be that whole thing there, right? Good.
Yeah, I think the part where you're getting the error is that second var expression, your initial block. It's just gonna be the symbol A, and if it tries to run a car on that, it's gonna fail.
Oh, this guy right here?
Yeah, it's gonna be an
It's
A,
just being A, so then.
not a list. It'll be the second time that process runs through for that initial block.
Yeah, right. But that's a legal expression.
Yeah, but just because that predicate needs a list.
Yeah, right. The predicate assumes a list, and I remember us saying that we're going to assume it's always a list. But a var expression doesn't boil down to a list. A var expression boils down to just the symbol, just like a lit expression boils down just the number.
You get the same problem if you put a lit expression.
Correct. Yeah. So if I said lit expression here and I put in a 2, it should be the exact same issue because in both of those cases I'm passing in a non-list. Yep. So, I mean, what's important here is that his solution was right to begin with, and maybe he had already followed the breadcrumbs as to why that was the solution, but I wanted to make sure I understood where are we passing it bad input. Because something you don't want to do as a programmer, you don't want to say, well, if I just say, is this guy a list, it's fixed, and you have no idea why you're having to ask that extra question, right? So we're not throwing duct tape on it. Now we know that before we can, where's our guy here? It was in remember expression. So we're going to say, well, I guess we can spell it out and say if it's a, if not list LC expression, then we boil down to false, else boil down to whether or not the things are equivalent, like that. You actually could just boil down to the or of those, I think. Yeah, so there's our 5 and 2. And then if we change this back to a var expression and say resolve A for me, but that A was defined, that A lived and died in that inner block. So it's no longer a viable variable. We're back to our old empty environment in this case. So we should get, I think, a false there when we try to look up A in the empty environment. Interestingly enough, we could say A, I don't know, 9 here. And this would be an example of shadowing because I think our apply environment gives us the first variable it finds. So we would see the 5 inside and then we get the 9 on the outside.
You're not using the test environment on applied program.
Oh, thank you. Thank you. So there's our 5 and there's our 9. All variables boil down to their most local definition. The most local definition of var A here was the remember expression at the beginning of this block. The most local definition of the var A here was our test environment that we started off with. So this is true to life for languages where we are lucking out that the way we wrote apply environment is to, when we extend an environment, we're always extending onto the front and we're searching from the front. So we will bump into our most local definition first. But if that's not the way we did it, then this wouldn't necessarily work. We might find, if we added to the end of our environment, let's say, we would always find the least recent definition of the most global version of our variable and completely omit the thing. So this allows us to have a local copy of A and a more global copy of A if we wanted to. Now, I can even make this work, though. I can go back to empty env. And now, as the first thing on my list, I can remember A is 9. Okay, so I can remember that A is equal to 9. Then I go into this block expression where I have a more local version of A, which is 5. So I'll now get the same thing, 5 and 9. Ruh-roh. That's on you, Blaine. I misspelled empty in V. There's well, I misspelled the parentheses on empty E and V. So there's our 5 and 9, based on me actually defining the remember expressions in here. That makes sense? All right. So there's a functional block expression that gives us the ability to have blocks inside of blocks with, let's call this accidental local environment, local scopes, because we're actually going to talk a little bit more about scope focuses. Like as we start upgrading our environments to support like lambdas and things like that, which we were going to chat about today, but that didn't happen. But this was still good, going through the debugging process. But in any case, if we're going to kind of reimagine our environment a little bit to be more robust for storing more interesting things. Sound like a plan? Okay, so we do not have class on the rest of this week because we're on break, fall break starting tomorrow. So the next time I'll see you is on Monday. What I think I'll probably do just to save time is, assuming I remember, I'll just put up the solutions to the exam. And then if you have specific questions about one of them, we can ask at the beginning of class or something on Monday, and I can go over why that one works that way. But for the most part, most of the exam people did all right on. There was just a couple of questions that were funky, but my intention was to use today's class to go over that, but I didn't. But in any case, I'll put this code up on Slack so you have like our current version of this guy, and I will see everybody on Monday.